Archimedes was a Greek mathematician and inventor. He lived in the 3rd century BC. He made many important discoveries in science and mathematics. One of his most famous discoveries is known as Archimedes' principle. This principle explains why objects float or sink in fluids. Fluids can be liquids or gases. Archimedes' principle is important in many fields. These include engineering, physics, and even everyday life. In this essay, we will explore Archimedes' principle. We will learn its definition, its history, and its applications. By the end, you will understand why this principle is so important. Archimedes was born in the city of Syracuse, in Sicily. He studied in Alexandria, Egypt. He was well known for his work in mathematics. He also made significant contributions to engineering and astronomy. Archimedes invented many useful devices. These include the Archimedes screw, which is used to lift water. He also developed war machines to defend his city. His work has had a lasting impact on science and technology. Archimedes was also a great thinker. He loved to solve problems and understand how things work. This curiosity led him to discover the principle that bears his name. It all started with a simple question: why do some objects float while others sink? Archimedes' principle states that an object submerged in a fluid experiences an upward force. This force is equal to the weight of the fluid that the object displaces. In other words, the fluid pushes up on the object. This upward force is called buoyancy. If the buoyant force is greater than the object's weight, the object will float. If it is less, the object will sink. This principle applies to both liquids and gases. For example, a helium balloon rises in air because the buoyant force is greater than the weight of the helium. Understanding this principle is key to many scientific and engineering applications. Buoyancy is the force that makes objects float. It is a fascinating phenomenon that plays a crucial role in our daily lives, from the way ships sail across the oceans to how fish swim in water. It is caused by the pressure of the fluid surrounding the object. This pressure is exerted in all directions, creating an upward force that can counteract the weight of the object. When an object is placed in a fluid, the fluid exerts pressure on all sides of the object. This pressure increases with depth, meaning the deeper you go, the greater the pressure. This pressure creates the buoyant force, which acts in the opposite direction to gravity. The balance between these forces determines whether an object will float or sink. The amount of buoyant force depends on the volume of the fluid displaced by the object. This principle is known as Archimedes' principle, which states that the buoyant force is equal to the weight of the displaced fluid. A larger object displaces more fluid and therefore experiences a greater buoyant force. This is why objects with larger volumes, like ships, can float even if they are very heavy. This is why big ships can float even though they are very heavy. Their large volume displaces a significant amount of water, creating a buoyant force that supports their weight. Buoyancy also explains why some objects sink. If the weight of the object is greater than the buoyant force, the object will sink. If an object is denser than the fluid, it will sink. Density is a measure of how much mass is contained in a given volume. For example, a rock sinks in water because it is denser than the water. The rock's weight is greater than the buoyant force acting on it, causing it to sink. However, a piece of wood floats because it is less dense than water. The buoyant force acting on the wood is greater than its weight, allowing it to float effortlessly on the surface. Understanding buoyancy helps us design better ships, submarines, and even understand natural phenomena like icebergs floating in the ocean. It is a fundamental concept in physics that has practical applications in engineering, biology, and environmental science. Section 5. The Eureka Moment. The story of Archimedes' Eureka Moment is famous. It is said that he discovered his principle while taking a bath. He noticed that the water level rose as he got into the tub. He realized that his body was displacing the water. Excited by this discovery, he reportedly ran through the streets naked, shouting, "Eureka!" This word means, "I have found it," in Greek. This story shows Archimedes' passion for discovery and his keen observational skills. The Eureka Moment highlights the importance of curiosity and observation in science. Archimedes' simple observation led to a major scientific breakthrough. This principle continues to influence modern science and technology. Section 6. Why ships float. Ships float because of Archimedes' principle, a fundamental law of physics discovered by the ancient Greek scientist Archimedes. Even though ships are made of heavy materials like steel, which are much denser than water, they can still float. This is because of their shape, which is designed to maximize buoyancy. Ships are designed to displace a large volume of water, which is key to their ability to float. The water displaced by the ship creates a buoyant force, which acts upward against the force of gravity pulling the ship down. This buoyant force is greater than the weight of the ship, allowing it to float effortlessly on the water's surface. The design of the ship's hull is crucial in ensuring that it can displace enough water to generate the necessary buoyant force. The hull must be wide and shaped in such a way that it can displace a sufficient volume of water to support the ship's weight, including any cargo it carries. This principle is also why ships can carry heavy cargo without sinking. As heavy cargo is loaded onto the ship sinks deeper into the water, increasing the volume of water displaced, which in turn increases the buoyant force. This delicate balance between weight and buoyant force allows ships to transport goods across the world, making global trade possible and connecting economies. Section 7. Why objects sink or float. In this section, we will explore the fascinating reasons behind why some objects sink while others float. Whether an object sinks or floats depends on its density. Density is a measure of how much mass is contained in a given volume. Density is the mass of an object divided by its volume. This means that if you have two objects of the same size, the one with more mass will have a higher density. If an object's density is greater than the fluid it is in, it will sink. This is why heavy objects like steel balls sink in water. If it is less, it will float. Lighter objects, such as plastic bottles, float because their density is less than that of water. For example, a steel ball sinks in water because its density is greater than water. The molecules in the steel are packed more tightly together than those in the water. However, a piece of plastic floats because its density is less than water. The plastic is less dense because its molecules are more spread out. This simple concept explains many everyday observations. For instance, why do some fruits float while others sink? It all comes down to their density. Understanding density and buoyancy helps us design better ships and submarines. Engineers use these principles to ensure that vessels can float and navigate safely. It also helps us understand natural phenomena like icebergs floating in the ocean. Icebergs float because the ice is less dense than the seawater. These principles are fundamental to many scientific and engineering fields. From designing everyday objects to understanding the natural world, density and buoyancy play a crucial role in our lives. Section 8. Applications in engineering. Archimedes' principle has many applications in engineering. It is used in the design of ships, submarines, and underwater vehicles. Engineers use this principle to calculate buoyant forces and ensure stability. For example, submarines control their buoyancy to dive and surface. They use ballast tanks to adjust their weight. By filling these tanks with water, the submarine increases its density and sinks. By emptying them, it decreases its density and rises. This principle is also used in designing floating structures, like oil rigs. Engineers must ensure that these structures displace enough water to support their weight. Understanding Archimedes' principle is crucial for these complex designs. Section 9. Everyday applications. Archimedes' principle is not just for engineers. It has many everyday applications too. For example, when you swim, you float because of buoyancy. Your body displaces water, creating an upward force. This principle is also used in measuring the density of objects. By submerging an object in water and measuring the displaced volume, you can calculate its density. This method is simple and effective. Even hot air balloons use this principle. The hot air inside the balloon is less dense than the cooler air outside. This creates a buoyant force that lifts the balloon. Understanding these everyday applications can help us appreciate the science around us. Section 10. Conclusion. Archimedes' principle is a fundamental concept in science. It explains why objects float or sink in fluids. This principle has many applications in engineering and everyday life. From ships to submarines to swimming and hot air balloons, it is everywhere. Archimedes' discovery has had a lasting impact on science and technology. His curiosity and observation led to a major breakthrough. This principle continues to influence modern engineering and science. Understanding Archimedes' principle can inspire us to explore more scientific concepts. It shows the importance of curiosity, observation, and critical thinking. Science is all around us, waiting to be discovered.